Hi everybody, good morning. Today we discuss about projection of points. Projection of points is often the first chapter in engineering graphics, or if you take the case of technical graphics also. So projection of points, what is the meaning? We are placing the points on the four quadrants and obtaining its projection on different planes like vertical plane or horizontal. We move into the details now. In projection of points, first we see what are the different quadrants. So we draw the quadrants. So these are the four quadrants in space. First quadrant, second quadrant, third and fourth. So first one. So we see now how different points can be placed or assumed to be placed in these quadrants and how their projections can be obtained on different planes like this. First we will see projection of point on the first quadrant. So we are placing a point on the first quadrant. What is the logical meaning of this? The point in the first quadrant looks like it is above HP and in front of VP. What is HP and VP? HP means horizontal plane and VP means vertical plane. So now we will discuss about the projection of point that is placed in the first quadrant. In order to explain the first quadrant projection, we have drawn the first quadrant separately like this, and a point P can be assumed to be above HP at a distance and in front of VP at a particular distance. So these are the distances of the point capital P from the different planes VP and HP. The intersecting line between the VP and the HP is termed as XY. That's why when the observer looks for the front view like this, in this direction, we get the projection of this point capital P onto the VP as small p dash front view. The same p dash has to be drawn above XY line, indicating the above HP distance like this. So this distance indicates the above HP distance of this capital P here. Whereas to get the top view, the observer has to view from the top. So in front of vertical plane, what is the distance of this P will be visible below XY. This is XY, so below XY on the same locus of P dash, we are getting small p for top view. So these are the front view and top view in the case of first quadrant. So if we want to mention the dimension line, we can mention what is this above HP distance and what is this in front of VP distance. This is about first quadrant projection. Now we move on to the point that is placed in the second quadrant. What is the logical meaning? Behind vertical plane and above horizontal plane. So we see the details now. Now we discuss about second quadrant projection. So a point capital P is assumed to be available in the second quadrant like this. So when the observer sees for the front view here, we are getting the projection on the transparent plane, that is vertical plane, as P dash, and likewise when the observer sees from the top, we get the top view that is also available above XY. So when we depict this in the format of XY line, we get the front view also above XY P dash, that is depicting above HP what distance the original capital P was available, and in the case of top view, that is also above XY, because XY is here, this portion is above XY, that is also coming on the same locus above XY line here. So all these are small letters whereas in the original question it will be capital P, the point capital P. So thus we get the front view and top view both available above XY in the case of second quadrant. So projection of point in the first quadrant and second quadrant got over. Now we move on to the case of third quadrant and fourth quadrant. Now we have come to third quadrant discussion. So here I have depicted the third quadrant alone in space, avoiding the first two quadrant and the fourth quadrant for avoiding confusion. So in the third quadrant also the point capital P is assumed to be available in the space, that is below horizontal plane and behind vertical plane. So this is the logical definition of a point that is assumed to be in the space of third quadrant. So now for this point, how the front view and top view will be available, that we will depict in the on the XY line as usual. So when we see the front view on the transparent plane, we get below XY line the front view, and when we go for the top view, we get above XY line the top view. Just the inversion of first quadrant. That's why first angle projection and third angle projection are reverse of each. Now for depicting the front view, below XY, the P dash will be coming like this. And on same locus, when we extend using a 2H pencil in the actual drawing, so when we move for the top view, above XY line we get the behind VP distance, that is behind the vertical plane. Originally at what distance the capital P was available, that we are getting here. So dimension lines also suitably we can add in this case of third quadrant. This is the fourth quadrant, that is our last quadrant in space, and here we have the horizontal plane like this and vertical plane like this, and our point capital P is available in this fourth quadrant space. Now we can easily imagine, after we have very well practiced the first three quadrants, so we can easily imagine when the observer sees for the front view, we are readily getting below XY the P dash, so we can depict the below HP distance, that is for P dash here. Likewise, when we look for the top view, so the HP becoming transparent, now we can imagine below XY region we are getting the top view of this object also, that is the notation is small letter p. So this is the case of fourth quadrant. In all these four quadrant discussion, we have avoided a specific distance to be mentioned, that is the various distances in front of VP, behind VP, above HP, below HP, so that we can suitably assume when the particular question comes in the exam. Dimension lines also wherever required, as we have depicted in the first quadrant, it is the same is applicable to all the remaining quadrants also. So thus we have discussed the projection of points on different planes when the point is placed in different quadrants, first, second, third and fourth. Normally in textbooks and other reference books, we follow a particular procedure of rotation, 90-degree rotation of the plane, so that we get the views. That will be little difficult and confusing. That's why this video is particularly designed for an easy explanation. Hope our explanation on the four quadrants was easy. Thank you. Hope now the projection of points on different planes is very clear. Thank you.